Okay, today we're going to talk about section 5.8, modeling with quadratic functions. There are three scenarios where I could ask you to produce a quadratic function. Those are a vertex and a point, x-intercepts and a point, and 3 points. If I give you a vertex and a point, the equation we're going to use is vertex form. If I give you x-intercepts and a point, we're going to be using factored form. So we'll just call x minus one number and x minus another number. And if we use 3 points, then we're going to be using standard form. Now, this last one is the only one we're going to use our calculator with. The other two will be no calculator. Okay, so.
Second floor class.
Sorry about that. The first one is going to be when we are writing a quadratic function given a vertex and a point. So let's say we're asked to write a quadratic function that passes through -5, 1 and has a vertex of -4, 3. Again, we're going to be using vertex form. And we want to remember that we already know h and k. So we're just going to plug them into our equation. So it's going to be x minus -4, which becomes x plus 4, squared plus 3. Now, you'll notice the only variable we have left besides x and y is a. And we're going to use the point -5, 1 to solve for a. We're going to plug -5, 1 in for x and y. So we're going to have 1 equals a times -5 plus 1 squared, plus 4, sorry, plus 4 squared plus 3. So we have 1 equals a, and then -5 plus 4 is -1. -1 squared is just 1, so our equation becomes 1 equals a plus 3, which means a has to equal -2. That means our equation is going to be y equals -2 times x plus 4 squared plus 3. Take a moment and write down example 2 and try it on your own. Here, when you plug in the vertex 1, -7, and then you plug in the point 3, -5 and solve for a, you should get a equals 1/2. The second type we're going to do is solving for our equation when we have 2 x-intercepts in a point. But the system is going to be pretty similar. We're going to take the information we're given and plug it into our general format. Y equals a times x minus the first x-intercept times a minus the second x-intercept, and solve for a. So we're going to have y equals a times x minus 1 times x minus -5. Now, we don't want to multiply these together. I know that's the instinct, but what we really want to just know is, what is our a value? So we're going to plug in 221. So we're going to have 21 equals 2, that's a times 2 minus 1 times 2 plus 7. Remember, it's not 7, I got ahead of myself, plus 5. So now we're going to have 21 equals a times 1 times 7, which means a has to equal 3. So our equation. Okay, so you can see for the last example, if you solve for a, you get -1. Sorry about that, I got disconnected from the sound. All right, our last example is going to involve 3 points, and that's the one we're going to get to use our calculator for. Remember, at any time, if I'm going too fast, you can always pause and rewind the video. All right, so now we have 3 points, and we're going to use standard form. Y equals ax squared plus bx plus c. And we're going to be using matrices. To do this, we're going to plug in our 3 points, and we're going to get 3 equations. Okay? I'm going to put the y on the other side because it's going to make more sense when I use matrices. Okay, so here we go. We have a times 1 squared plus b times 1 plus c equals 3. Then we have a times negative 3 squared plus b times negative 3 plus c equals negative 5. And then we've got a times 0 squared plus b times 0 plus c equals negative 2. What I'm going to do is I'm going to turn these three equations into three matrices. To do that, the first thing I'm going to have to do is move my turkey. Move it, turkey. Okay. So I have a, b plus c. Let me rewrite these actually. And then I have 9a minus 3b plus c. And then I've got 0a, 0b plus c. Now obviously c is negative 2. That one's kind of nice. It works out that way. But if you don't have one that goes directly to c equals something, then you're going to have a problem. And this is where we're going to build matrices. Our matrices are going to be the coefficients 1, 1, 1, 9, negative 3, 1, 0, 0, 1 times a, b, c equals 3, negative 5, negative 2. And remember, we're going to put this into matrix A and this into matrix B. And to find this unknown matrix ABC, we're going to type in A inverse times B. Let's grab our calculator. Go to our matrix menu. So we've got 1, 1, 1, 9, negative 3, 1, 0, 0, 1, and then I'm going to edit matrix B. And that's going to be 3, negative 5, negative 2. Now I'm going to get out of that and go to matrix A inverse. Where's that button? Oh, no, second. Ah! Get out. Inverse times matrix B. Cool. And there are my A, B, and C values. 1, 4, and negative 2 means that the equation is going to be 1x squared plus 4x minus 2. And that's how we're going to write the equation given 3 points. And let it